Hi guys, in today's video we're going to be learning to work out an unknown value where the value that we're trying to work out has been subtracted from a larger value. Now the concepts in this video are slightly more challenging, and so you're going to need a really good grounding in the basics of algebra before progressing onto this. So I've done two algebra videos that come before this. One is a sort of pre-algebra introduction where we're just thinking of it as a fill-in-the-blanks activity. And the second one looks at the more formal method of doing algebra. If you've got a good grounding in them, then you should understand this completely fine. But if not, probably best to go back and have a look at those videos first before progressing onto this one. So, looking at this problem here, what we're being told is that we've got 30 take away something equals 25. So 30 take away what equals 25. Now, if we're just thinking of this in a fill-in-the-blanks way, we can get the answer quite easily. So we just think 30 take away what equals 25. Well, 30 take away 5 equals 25. So already we've worked out that A equals 5. And we're able to do that just purely in our heads. However, there's lots of situations where we can't necessarily just do it mentally. So in that case, we're going to have to actually apply a formal method in order to do that. So here's a way of thinking about it. In algebra, we often think of things as being like a set of scales that we need to balance. And we had 30 here, but we'll see that A has been taken away from it. So we haven't really got 30 anymore. We've got 30 take away A. And that weighs the same as 25. So 30 take away A equals 25. Now we want to find out what A is. But here we've got a minus A. We're trying to work out A. So what we need to do, first of all, is we need to add A back on. So I'm going to add A on here. Now we've got the whole 30. We have a full 30 now. But because I've added A to that side, it's going to make the scales unbalanced. So this side is just going to have gone down. So to rebalance the scales, I'm going to have to add A onto the other side. Remember, in algebra, whatever we do to one side, we must do to the other side. So now the scales are going to be balanced. So writing that down, the actual process, we started off with 30 minus A equals 25. Now though, we've actually got just 30, because we've added the A back on, and that equals 25 plus A. So 30 equals 25 plus A. Now, there's no reason we couldn't write that round the other way. We could write it round where the A is on the left-hand side as we're used to. But it doesn't matter what's on what side of the equal sign. In maths, you can swap things on either side of the equal sign that still makes sense. So, now, it is just a normal algebra sum. We've got A, I'm going to read it from right to left, so we've got A plus 25 equals 30. Now, if you've looked at the last video, you should know how to solve this quite easily. We're going to take off this 25. That 25 we want rid of. But now the scales are going to be unbalanced. So once again, whatever we've done to one side, we have to do to the other. So I'm going to take off 25 from this side, which is probably going to be quite a lot of it. So if we imagine that we've taken off 25, we're only going to have a tiny bit of it left. So what we'd actually be looking at is that A equals 30 take away 25. And now we've proved that A equals 5. Now our working looks back to front here, but it makes sense mathematically. 5 equals A equals 5. You're saying the same thing there. So we've demonstrated it. So this would be worth 5 on this side now. So we know that A is equal to 5. We did that by adding A onto both sides. So then we ended up with 30 equals 25 plus A. And then we treated it as a normal algebra sum where we got the numbers on one side and the letters on the other side, and then resolved it so that we got our final answer. So the process is fairly simple. It's just the concept of having to add on an A. The reason for that is that this isn't really an A, this is a minus A. Minus A is the opposite of A. So if we have a minus A, we hate minus numbers in algebra. We want to try and get them positive where we can. Or we hate minus unknowns in algebra. So if we have a minus unknown, a minus letter, we want to try and make it a positive letter. And we do that by adding that letter back on. Now that last one we were able to do in our heads quite easily. This one is probably a little more challenging just to do in our heads. So by looking at this straight off, the calculations are a little bit harder. I can't just work it out straight away. So I am going to stick to our actual method here. So if we write it out, 69 minus A equals 17. Now I'm seeing that minus A there. We hate minus A's. And we see here that what this is what would have been 69, but we've taken away A. So what we do, we add A onto here, which unbalances the scales, makes it too heavy. So then we add A onto this side, and that rebalances the scales. So what we've done is we've done 69 equals 17 plus A. And the scales are balanced there. But we've got a mixture of letters and numbers on this side. We want just letters on one side and numbers on the other side. So to get the numbers on one side, what we're going to do is we're going to take off this 17. That 17 there, we want it gone. But that unbalances the scales, so again, we're going to have to take off 17 from the other side. So we're going to rub off 17's worth. Let's imagine that that was 17 that we rubbed off. So this is actually now 69 take away 17, if we think about it, because we took away the 17. So, coming back to our actual equation, we know that 69 minus 17 equals A. Now's the part where we're actually going to have to calculate that. We could do it in our heads, we could use a calculator, we could use a chimney sum, a column sum, whatever you want to call it. In fact, that's what I'm going to just do very quickly. So 69 minus 17, 2, and we've got our answer then. So A equals 52. And that's our answer. So this A here is the same as 69 minus 17, which is 52. Finally then, let's do one purely mathematically without any diagram to help us. So, our problem here, 42 minus A equals 15. We've got letters and numbers, but we have that minus A. We hate minus A's. We want to make it a positive A. So we're going to add A to each side. So I'm imagining that I'm adding A on here. That's just going to give me 42 on this side. But on this side, it's going to give me 15 plus A. So now I've got letters and numbers here. I've got A plus 15. I don't want A plus 15, I want just A. So how do I get rid of that 15? I take it away. So on this side I'm going to have A. But that means I need to take it away on this side. So on this side I'm going to have 42 take away 15. So finally, very quickly, we could just do it as a formal subtraction sum. So 2 minus 5 we can't do. 12 minus 5 is 7. 3 minus 1 is 2. So A equals 27. Now you've seen it a few times. The takeaway message is minus A's, we get rid of them, and then we just treat it as a normal algebra problem. Cheers guys!